Hello and welcome to class today where we're going to finish up section 4.1 and go through 4.2. And so we're going to talk about non-homogeneous equations or non-homogeneous equations. So given the differential equation a sub n, you know, dny over dx to the n all the way up to x sub 0 xy equals g of x, notice that it's non-homogeneous because it's now not equal to 0. It's equal to some, function of x. So any function yp free of arbitrary parameters that satisfies this differential equation is called a particular solution or particular integral of the equation. So theorem. Let yp be any particular solution of the non-homogeneous linear nth order differential equation on interval I, and let y sub 1, y sub 2, all the way to y sub n be fundamental set of solutions of the associated homogeneous differential equation on I. Then the general solution of the equation on the interval is going to be y equals c sub 1 y1 of x all the way up to c sub n yn of x plus y sub p, that particular solution. The function y sub c is called the complementary function. This complementary function is the function where it's the solution to the homogeneous part of the differential equation. So that y sub c is going to be your homogeneous part. So the c sub 1 is all the way up to c sub n. Y sub n is going to be the complementary function, the solution to the homogeneous part. The particular solution is going to be the solution of the non-homogeneous part. So verify example A. We want to verify the given two-parameter family of functions is the general solution of the non-homogeneous differential equation on the indicated interval. So here we have y double prime plus y equals secant of x. So there's our differential equation. And we're told that this is a solution y. C sub 1 cosine of x plus c sub 2 sine of x plus x sine of x plus cosine x natural log cosine x. And then we're going to use negative pi over 2 and from negative pi over 2 to pi over 2 as our interval. Alright, so let's go ahead and we have y. Let's find y prime and let's find y double prime. So looking at y prime, just take the derivative of everything. Derivative of c sub 1 cosine of x is going to be negative c sub 1 sine of x. Derivative of c sub 2 sine of x is plus c sub 2 cosine x. Derivative of x plus sine x is going to be plus, take the derivative of x, which is 1, derivative of sine of x, keep sine of x, plus the derivative of sine of x, which is going to be cosine of x, so x cosine x, plus the derivative of cosine x, which is going to be minus sine of x, times natural log cosine x, plus the derivative of, I'll keep the minus there, derivative of natural log cosine of x is just going to be minus sine of x over cosine x. So that, I'll write it out and then show you how it's going to cancel. So the first and then sine of x over cosine x. Well, that sine is negative, so I'll put it out in front. They're going to cancel each other out, and so then what we can say is just minus sine of x. Now we have y double prime. Right, so y double prime, go ahead and take the derivative of what we just took. So minus c sub 1 sine of x is going to be minus c sub 1 cosine x minus c sub 2 sine of x. Derivative of sine of x is going to be plus cosine x. Plus x cosine x, so plus cosine x. Derivative of cosine x is minus x sine of x. Take the derivative of sine of x, which is going to be cosine x, so minus cosine x. Natural log cosine x. I take the derivative of natural log cosine x, which is going to be sine, negative sine, so that's going to be a plus. And then we're going to have a cosine out in front. And then we have a sine out in front, so it's going to be sine squared x over cosine x. Make that a little bit better. Minus cosine x. Alright, now let's go ahead and add our substitution. So we're going to do y sub 2, which is going to be negative cosecant 1 cosine x. And again, you can skip this. This is just notes. I'm just going to rewrite everything. And I would never suggest that you rewrite this. I would just look up and cancel everything. But I just want to write it all out so that you have these notes. So minus x sine of x minus cosine x natural log cosine x plus sine square root of x over cosine x minus cosine x. And again, if you wanted to change it to sine times tangent of x, you'd be my guess, the sine squared over cosine x. Let's see. Well, it's not. I should not say cosine squared. I should say cosine. All right. Now let's go ahead and say plus. Now here's our y. C sub 1 cosine x plus c sub 2 sine of x plus x sine x plus cosine x natural log cosine x. And that all this is supposed to equal secant x. So let's just go ahead and try to cancel out what we can. So I'm just going to highlight so you don't really see things crossing out. So this is minus 1 cosine x should cancel out with that, plus 1 cosine x. C sub 2 sine of x cancels out with that, plus cosine x is going to cancel out with that. Minus x sine of x cancels out with plus x sine of x, minus x cosine x natural log of x cancels out with plus there. So the only thing that we're left with is this. Cosine x plus sine squared x over cosine x. And this is supposed to equal secant x. Well, can we make that equal secant x? Yeah, let's see. Let's pull out a 1 cosine x. If we pull out a 1 cosine x, we're going to get cosine squared x plus sine squared x. And that's equal to secant x. Well, cosine squared plus sine squared is 1, so 1 over cosine x times 1 is equal to secant x, which is true. Right? And so we've found that that is a solution to our non-homogeneous differential equation. Alright, so theorem 4.1.7, the super... Oh, here, let me do this in the next video.